Well, in the first part of the partial exam, we have 5 questions. And the first one says, by which factor you must decrease the tension to have a half of the speed of a certain wave. For this we know that the velocity of a wave is defined by the square root of the force over mu. And if we need to decrease by half the speed, we need to make them equal. And by this, we know that we can pass the square root to the other side as the power to 2. And this square root cancels, and we have left with 1/4 of the force 1 over the mu 1, and that it's equal to the force 2 over mu. And then since we need to find by which factor you must multiply the second force, all we need to do is pass this 1/4 multiplying, and we have left with force 2 times 4 over mu. So the factor is going to be 4. And then the second problem says, order the colors red, yellow, and blue by their wavelength from the shortest to the longest. So we know that the ultraviolet waves are like this with a short wavelength. The waves with the longest wavelength are the infrared waves with a larger wavelength because they have a lower frequency. And in the middle, there are the colors like yellow. So this is the blue, yellow, and red. So the order would be blue, yellow, and red. Then the third problem says that we are in the middle of a street, and then a car with a certain velocity, we are able to hear a sound with a frequency of 80 Hertz. At the time the car passes us, we hear the same sound with a frequency of 72 Hertz. So we need to find the velocity. For this can be explained by the Doppler effect. So this is the formula to find the Doppler effect, and it's a prime frequency times it's equal to the original frequency times the velocity of sound times plus or minus the speed of the observer. In this case, it's 0 because we are standing in the middle of the street, over the velocity of the speed of the sound minus the velocity of the car, since this object is approaching us. Then, at the time it passes us, we have the next formula. The 72 Hertz is equal to the frequency times 343 times 0 plus 0 over 343, the speed of of sound, plus the velocity of the car. We know that it's the same car, so it has the same original frequency, and we need to find B. So the thing we need to do is to make them both equations equal, and we have left with this. And then we have 80 times This can be cancelled because it's in both sides of the equation. And by isolating v, we can get to the conclusion that the velocity is equal to 18.05 meters over second. And the fourth problem says that we have a radius 3 with a sound level of 80 decibels, and the power is reduced by a factor of 25. So we need to use the sound level equation, which says that it's equal to the 10 log of the intensity over intensity 0. So by this we know that 80 decibels, it's B, 10 log of the intensity we don't know, over the I0, that is 1 times 10 to the minus 12. Then we need to isolate the intensity. That gives us a value of 1 times 10 to the minus 4. Then we need to apply the formula of intensity. It's equal to power over 4 pi radius squared. Since we know that the power is reduced by a factor of 25, we can express that the intensity, the original intensity, is divided by a factor of 25, giving us a new intensity that is 4 times 10 to the minus 6. And this value can be reinserted here in another sound level formula. Log this 4 times 10 to the minus 6 over 1 times 10 to the minus 12, obtaining a new sound level of 66 decibels. And the last problem says that that the temperature affects the sound level, because in the air, if the temperature rises, it move more fast the particles in the air, creating more kinetic energy between them.